Hey, good morning, everyone. I'm Davide. I'm from Xinnor. I'm the Chief Revenue Officer from Xinnor. And today I have the pleasure of having with me my key colleagues. And we will be talking about xiSTORE, our new software-defined storage for the HPC and AI market. Before we start with the presentation, let me tell you that you can interact with us through the chat on YouTube. So if you have any question, please write them in the chat and we will address them at the end of the presentation. So without any further ado, let me start introducing the team. So today you have me. I'm the Chief Revenue Officer. You will hear from Dmitry, our CEO, and from Sergey, our VP of Strategy. You see in this chart, we are a very seasoned people, which is a bit painful. So I like to think about myself as still being a young guy, but those numbers on the chart speaks by themselves. Who is Xinnor? Xinnor is a relatively young company. We were founded just 1.5 years ago in Haifa, in Israel. But in reality, our technology has been developed for much longer than that. In fact, Xinnor inherited all the intellectual properties that were developed by a company called Radic. And as a matter of fact, today we are a young company with a very well market-proved technology. We're about 40 people. Most of them are in development. And our mission is to develop the fastest RAID engine in the market. We are growing internationally. We have something like 25 active partners globally, and we are adding new partners every month. And we already have 100 petabytes of end customer data that are managed by our technology. We partner with very large companies. We are part of the Inception program of NVIDIA. We partner with Western Digital and Kioxia and Scaleflux and Declustered when it comes to the SSD world, and also with the other partner that you don't see on this chart, but will be added pretty soon. And we also like to engage with a specialized company like Atoll, like Limbit, BGFS is one of our key partners, and Ingresys. With some of those partners, specifically with Western Digital and with BGFS, we have been awarded the Best of Show at the recent Flash Memory Summit for the most innovative customer implementation. What do we do? As a company, our mission is to develop the fastest software RAID in the market. And this software RAID is an existing product which we call xiRIAD. I'll briefly talk about xiRIAD throughout the presentation, but that's really the core of our technology. And xiRIAD today is used in many different verticals. We have customers in media and entertainment where they use xiRIAD for post-production servers. We have customers using xiRIAD for accelerating data loggers, data collector in various industries like network monitoring or autonomous vehicles development. And we have customers using xiRIAD for accelerating database in many different verticals and applications. For example, we have customers doing high-frequency trading using xiRIAD. But as a company, we love working on HPC. That's where most of us are coming from. And we have use cases of xiRIAD together with BGFS, but also with Lustre at various universities. One of our customers in the HPC space, actually our largest customer in the HPC space, is a Japanese scientific institute. They came to us. They used to be a long-standing customer of Radix, and they asked us to develop something more than just the RAID engine. So they asked us to combine our RAID engine with well-known, used parallel file system to build a kind of a custom solution that will be deployed pretty soon in all their data center. And that's how we came up with xiSTORE. So xiSTORE started as a custom development, and now we are ready to make it available for the large audience worldwide. So what is xiSTORE? xiSTORE is a software-defined storage for the HPC and artificial intelligence market. It's based on xiRIAD, and we combine xiRIAD with Lustre cluster parallel file system and with commodity hardware. So we get the cost efficiency of using commodity hardware, the flexibility of using virtual machine, and the scalability that we can get through Lustre. So the key ingredients of xiSTORE are, first of all, xiRIAD, our NVMe, special NVMe software RAID. And I will talk about that in a minute. But then when we deal with high-performance computing deployment, we need to be able to provide not only performance, but also cost-efficient capacity. And for that reason, we need to use hard disk drive. Hard disk drive are still the best technology when it comes to dollars per gigabyte. And but to be able to deal with hard disk drive, we also need to be able to address the weakness typical of this technology, which is the lower speed, the higher failure rate, and the rebuild time. And for that, we develop from scratch our own implementation of Declustered RAID. The focus of our customer in Japan is data integrity. So all the solution is built as highly available without any single point of failure. They wanted flexibility, so we develop our control plane to manage the virtual machine. And on top of those virtual machine, we are adding Lustre cluster parallel file system. So those are the key ingredients. And then xiSTORE is made of several building blocks. Each building block is a dual controller architecture with shared drives. And then you can, each of those building blocks can be based on NVMe or on hard disk drive. And we can combine multiple of those building blocks as needed to achieve the required performance and the required capacity. So with this, let me hand it over to Sergey, who will give more technical information about the architecture. Over to you.
Okay, hey everyone. Thanks, Davide. So it's time to talk about how our building blocks operate, and let's start from building block for spinning drives configuration. And each building consists of two nodes, just two commodity servers, and our RAID engine instances are running on each node. And here you can see three RAIDs on each node. You can see DCR1, DCR2, RAID 1, and DCR3, DCR, and again RAID 1. DCR means declustered RAID, and we will talk about declustered RAID in details on one of the next slides. And as we mentioned before, to operate a fault-tolerant RAID array, we need to have shared disk shelf, and RAID arrays are passed inside virtual machines using VirtIO technology, and as a result, the performance of block devices inside virtual machines are almost equal to their raw performance. So you can hear OST1, OST2, and journal. This is block devices which represent our RAID passed to virtual machines and used by parallel system instances. So inside virtual machines, Lustre services operate, and thanks to xiRIAD technology, we can pass high-performance InfiniBand and Rocky adapters into these virtual machines, and our control plane directly manage our arrays, virtual machines, parallel file system services, monitor hardware, etc. And as basic solution, we have two servers connected with two SAS JBoards, and SAS JBoards contains hard drives for data arrays and SAS SSDs for file system journals. On each controller there is single virtual machine running, but in future you will be able to add more virtual machines. And as I mentioned before, each controller has two RAID arrays for data and one array for file system journal. And for data array, we recommend to use Declustered RAID with dual parity, and it's better to have Declustered RAID consisting of 42 drives. In such configuration, we will have 8 chunks for data, which is very good for typical Lustre I/O. Okay, next slide. Yep. As for NVMe-based configuration, we recommend to use something like SBB type platform with 20 or 24 drives, and it's very cool that we can combine metadata server and object storage server roles in single enclosure. In case of where we combine metadata and object server roles in single enclosure, the optimal setup is to build 4 RAID 6 arrays from 10 namespaces and allocate the remaining 4 drives and 8 namespaces for metadata server. As for system based on hard drives, single virtual machine will be used on each node, and each virtual machine serving 2 OSTs. And again, block devices are passed through to virtual machine using VirtIO, and to achieve the maximum performance, we allocate cores among RAID, virtual I/O threads, and virtual machines. And for NVMe configurations, there is no need to assign separate device for file system journal. So our software is PCIe 5 ready, but we just started our journey with PCIe 5 configurations, and Davide will talk about our result on PCIe 5 hardware, but PCIe 4 based hardware are well tested, and we recommend to use PCIe based hardware. So this slide shows the hardware configuration for simple building block based on NVMe devices. This simple block can be used as metadata server for large clusters, as well as object storage server for as high performance tier, and of course combine roles of metadata server and object storage server. As a platform, we use Viking Enterprise Solution VSS 2249 system, and each node of building block has 64 core CPU, 256 gigabytes of RAM, and 2 NVIDIA Connected 6 HCAs. As storage backend, we use 24 or 20 drives from Kioxia, and each drive is divided into 2 namespaces, and this approach allows get better PCI Express lanes utilizations. As well, we can increase amount of spare space, which provide us with more stable write performance. And having such configurations, having such configuration, we obtain a system that provides read and write performance of 80 gigabytes per second. From perspective of 10 clients, we used IOR benchmark utility to achieve such results, and IOR configuration we will show at the end of the presentation. And we support almost the full read performance even in case of degraded RAID, and the performance per rack is close to 1.5 terabyte per second from single rack. Okay. As for HDD based configuration, we again employ 64-core CPUs, and each node is equipped with 192 gigabytes of RAM and single NVIDIA Connect X6 HTA. And to connect JBOS, we use Broadcom HBAs, and as a backend, we utilize two JBOS 102 bay JBOS from WD. In total, we have 204 drives, and as a result, we are getting 21 gigabytes per second for writes and reads from single building block, and we can fit 3 building blocks in single rack, having more than 6 gigabytes per second from single rack. Okay, Davide, it's time to you.
Yeah, okay, so let's talk about why xiSTORE. What's the advantage of xiSTORE compared to what's already available in the market? So we developed xiSTORE with these three key targets in mind. First of all, performance. We get performance through the fact that we use xiRIAD, our fastest RAID engine, and we get performance when it comes to rebuild time of hard disk drive, and I'll show you in a bit. The second pillar is the reliability. That was our customer in Japan is maniac about data integrity. So not only we implemented very advanced RAID, but all the solution is built as a highly available cluster. And we also add a module for managing silent data corruption, so to protect silent data corruption that could happen in background. And then the third big advantage is the ease of integration. So we are using a very well market-proof distributed file system. We are given the flexibility of using a virtual machine. And then, last but not least, we are building the solution on commodity hardware. We do have a preliminary approved vendor list of what we tested, but we will be working with our partners on validating new hardware. And by design, there is no specific lock with any specific hardware. So those are the three key advantages of xiSTORE, and let me dive into each of them. So let's start with performance. You might remember at the beginning I said our mission is to develop the fastest RAID engine in the market, whether it is software or hardware or GPU assisted or whatever. Today we have the fastest solution in the market. It's called xiRIAD. It's industry proved, has been in the market for quite some time, and with this software we are able to exploit up to 97% of the raw performance of the NVMe drives, while alternative solution they can only get up to 51%. But this might look like marketing. So let's look at real numbers. And just a few weeks ago at the supercomputing event in Denver, we were there showcasing our latest result with 24 PCIe Generation 5 from Kioxia, the CM7. And as you can see on this chart, we achieve amazing performance. We actually got to an efficiency rate which is 100% in random and 92 and 97% in sequential, with incredible 310 gigabyte per second sequential read and 144 gigabyte per second sequential write in a RAID 5 configuration to RAID 5 configuration. So those numbers speak by themselves about the great performance that we can achieve with our xiRIAD. But then, as I said, when we deal with hard disk drive, there are more problems we need to cope with. Hard disk drive, they are more prone to failure because of their mechanical nature. I read recently the latest Black Blaze release of their testing on hard disk drive, on their failure analysis. And they quote 1.47 annualized failure rate as an average. So when we talk about HPC installation, we're talking about thousands of drives in the same cluster. So with 1,000 drive, you should expect at least 15 failures every year. With a rebuild time of the hard disk drive, of modern high-capacity hard disk drive, it takes about 2 days to rebuild a 20 terabyte drives. So if you consider 15 drives failure, 2 days rebuild time, it means that we have 30 days in a year where our system will be busy rebuilding drives. And that's when the system can be vulnerable. So that's why we had to develop an innovative Declustered RAID. And this innovation comes from the fact that we develop a predefined matrix of placement for data, parity, and spare. And by doing that, we can increase the speed of the rebuild time of hard disk drive by 10 times versus conventional RAID, and even 2.6 times better than Declustered RAID under ZFS. And that's because of those predefined matrix. So if we were to use a conventional RAID, the rebuild time would be limited to the speed of the single drive. By using our own implementation of Declustered RAID, those matrices are designed in such a way that we can distribute data parity and spare among as many drives as possible. And that means that when we need to rebuild the drive, we have a concurrency from multiple devices that drastically improve the rebuild time performance. And when I say drastically, here I can show you some real data. So we did some testing with a 4 terabyte drive from AGST, the best drives in the market. And we tested them in different RAID configuration, as you can see in the table. When we were using conventional RAID to rebuild just a 4 terabyte drive, that's a very low capacity drive, it took us 25,000 seconds. That's about 7 hours. Then if we implement ZFS Declustered RAID in different RAID configuration, in the best situation, we can go down to 11,000 seconds, 11.3. And if we compare this with our Declustered RAID implementation, when the drive is full, we go down to 4,000 seconds, which is 2.6 times faster than ZFS Declustered RAID. Then the second big advantage is reliability. And for this, I need, again, the help of Sergey.
Thanks, David, again. So, what is cool? We support very wide range of configurations, and you can start with very simple dual node configuration where OSS, MDS, and management roles are combined. For us, this means we should take care about simple dual node configuration, and we should take care about high availability without the risk of split brain issue. So that's why process is performed in two stages. In the first stage, the heartbeat service must determine that second node has stopped responding. But there can be several reasons for second node. For example, simple network adapter failure, and that's why as a second stage, we check special metadata on the drives to check if any RAID activities we can detect on the drives. In case of lack of RAID activity on the drive, node has stopped providing. Let's me switch the slide. Yep. And in this case, we start a failover process. Failover process is managed by our own cluster manager. Our cluster manager is responsible for our RAID volumes and also Lustre services. During the failover process, we migrate our volumes and connect volumes to the virtual machine which exists on the second node, and in such scenario, virtual machine serve all the OSTs for both nodes. So you can see on the picture that USD both nodes, node controller one owned RAID DCR1 and RAIDs DCR1 and DCR2, and RAID 1 for file system journal, and after failover, controller 2 owns all the RAIDs, and virtual machine serve all the OSTs, object storage targets, and all the journals. Okay. And a lot of our clients are sensitive to data integrity, have developed a way for scanning the surface of arrays for silent data corruption. We support both just verification only, and verification and error correction modes, and error correction is only possible with sufficient number of parities in the array, and data recovery in case of silent data corruption found is similar to a standard partial reconstruction operation. The corrupted data block is rewritten with correct data based on rest of the data striped and parities. So, as I mentioned before, our cluster manager is responsible for our RAID volume and Lustre services, and we have dedicated virtual machine management because we allow to set up new roles and set up new instances of object storage servers in minutes. And this means we need to provide some possibilities to create virtual machine, to manage virtual machine, to arrange RAID volumes to virtual machines to achieve the maximum possible efficiency. So we developed our own virtual machine management, and we have paid particular attention for tuning of virtual interface performance. We have some recipes how careful distribution of CPU cores can provide the maximum possible performance over recipes, taking into NUMA nodes, CPU architectures, and of course we ensure the minimum distance of data pairs. So for now we are able to achieve the performance inside virtual machines close to bare metal performance, bare metal speeds of several tens gigabytes per second of gigabytes from single virtual machine. Okay, Davide?
Yeah, the third main advantage of our solution is the seamless integration. And that means that we make it easy for the customer to deploy xiSTORE. And we make it easy by using Lustre. And go ahead, Sergey.
Yeah, I believe everyone here understands what Lustre is, but let's talk about this again. So Lustre is open sourced, parallel distributed file system, widely used for large-scale HPC environment. It's designed for high performance and ability to store multiple petabytes of data, and typical Lustre architecture consists of several key components like management server responsible for system configuration, and metadata server which handle metadata operations like directory listening, file creation, file deletion, and permission management. Metadata target is a storage when metadata is stored. Object storage server manages the actual file data, and object storage target is a physical storage where files stored, and of course clients access data and use file system. But in our approach, we combine metadata server and metadata target, and object storage server and object storage target in single box, which allows to decrease costs and decrease file system latencies, and increase performance because we decrease the number of interfaces between different layers, but we still provides high availability. We still provides ability to scale up and scale out the system. And let's talk how the systems can be scaled up and scaled out. So we support both options: scale up by adding more drives in each building blocks, and we support new nodes, and scale out may require vertical scaling of metadata server, and because we use commodity hardware, it's easy to do this. You can easily change CPUs on controllers, you can add more memory, you can replace and add NVMe and hard drives with more capacity, with higher performance metrics, and there is no vendor lock-in. You can add drives from different vendors, and as I said, OSS can be easily scaled vertically by adding new JBots and creating new virtual machines. As I mentioned before, you can add new OSS instances, just connecting new JBots and adding new virtual machines in several minutes. Okay, so we are talking about software-defined approach. We utilize commodity hardware, so any modern server CPU from Intel or AMD are supported, and we support all SAS configurations with SAS drives, I mean spinning drives and SSD drives and NVMe drives. You just need to have dual ported drives because we support only shared drives configuration, and most of modern motherboards are supported. You can use any SAS JBOD, and you can use any Broadcom HBase to connect JBODs, and for now only NVIDIA Mellanox 5 and Mellanox 6 Rocky and FiniBand adapters are tested, but it will be easy to support different configuration from different vendors in future if you need. Okay, yep, Davide?
Yep, and we enable the customer to customize our control plane, so you can have your logo instead of Xinnor logo, and look and feel that might be relevant for you and your organization. Yeah, then on YouTube, on our YouTube channel, at the link here, we are making available some video where we demonstrate how easy it is to create RAIDs, allocate RAIDs to the virtual machine, manage the failover capabilities. So there are multiple videos that our engineers put together to explain visually how to operate our control plane. And with this, I said at the beginning that xiRIAD is not just an R&D project. xiSTORE actually started as a custom development. And in the next few slides, I hand it over to Dmitry, our CEO, to explain this specific deployment at our largest customer in Japan.
Thanks, Davide. Thanks, Davide. It's my pleasure to meet all of you on our webinar. I see a lot of questions at the chat, and I encourage you to ask even more questions, and I can promise you that in case if we would not have time to answer all the questions during this live session at the webinar, we will do one-to-one session for everybody who will ask a question for us. And most complicated and most difficult question to us, most pleasant and most interesting. So please ask any questions. Okay, so as Davide told, it's not only theoretical exercise what we do. It's we have real projects. At the present moment, most of them are out of Japan, with our partner, with whom we are cooperating more than 8 years at the present moment. It's a project in a big university, in scientific foundation research centers, with really big installations. The biggest one at the present moment is an installation with more than 1,000 drives. Related to this store, we do with our Japanese partner implementation related to the can I ask you? Okay, now I see the next slide. We do real implementation both for HDD and NVMe. Related to the HDD, we construct building block, which is much more exhaustive than the business block that was provided at the beginning of the presentation. It includes more than 500 HDDs, which are in 7 JBODs. And this was done by 20 Lustre clients. At this implementation, we see a really great performance. I would like to pay your attention at the right part of the slide, where you can see impressive 50 gigabytes per second for your test related to the write. Related to the read, we have the same 50 gigabytes per second. From the one single client, we have more than 11 gigabytes per second. And what is extremely important is that in RAID, in the Declustered RAID configuration, we have more than one half of raw drive performance. In this case, raw drive performance is 96 gigabytes per second by IOR and Lustre, and all our software stack, including dual controller, including virtual machine management, we have more than 50 gigabytes per second. And by the way, our RAID engine could provide even better performance. It will be 80 gigabytes per second. But due to Lustre stack and virtual machine management, we have 50 out of 80. And when we compare this metric with the best results at the industry, we see that we have very competitive result, very competitive solution here. Related to the NVMe, here I will be more brief because Sergey provided all the numbers related to the NVMe. We do testing with 20 NVMe drives, which were organized on a dual controller with 4 OSS. And we have very interesting results here that IOR give to us 63 gigabytes per second for RAID. It's more than 95% of raw drive performance. More than 95 from the raw drive performance. For RAID, we have even more impressive 90 gigabytes per second. For single client, we have 15 gigabytes per second just from one Lustre clients in our NVMe configuration. It's pretty all about this customer implementation. It's just one of the examples. We have much more examples that would like to share with you in one-to-one session, as well as you can address any questions again on Q&A. So, wrapping up this presentation, I would like to say that the key 3 competitive advantages of our solution our 3 pillars are unbeatable performance, outstanding reliability, and seamless integration. So now I think it's a good time to go to the Q&A session, and we see a lot of questions at the chat. So Sergey, Davide, please help me as well. Daniel, please help me to ask all the questions that we have in the chat.
Yeah, let's go through the question that we see on the chat. So the first question is from Joseph. Is the RAID engine is a cluster? Oh, I see. Okay, let me read the one that I see in the chat. Is the RAID engine is a cluster aware, or the cluster awareness comes from Lustre?
So yes, I will answer. So yes, our RAID engine is cluster aware and is developed with mind to implement it as a part of dual controller configuration, and it developed in the idea in mind that it could be implemented in disaggregated storage infrastructure. So yes, it's cluster aware. It supports migration between different nodes. It works only in active passive state now. And as for xiSTORE, we have own cluster manager integrated with our RAID engine, but for wider installations, we have some customers which use only RAID engine, not full solution xiSTORE. We are developing pacemaker resource again. We're able to manage our RAID in cluster environment. Yep. Okay,
then the next question from Siva Prasad is it possible to replace existing drive in already RAID configured setup, and is it auto-construct the new device for the settings?
Yes, it's possible to replace existing device, of course, for all RAID types. I mean, conventional RAID like RAID 5, RAID 6, and nested RAIDs. As for declustered RAID, yes, we support basing with new one, and conventional RAID supports vertical scaling, which means you can one by one replace devices with new one with larger volume, increasing RAID volume.
Okay, and next question, what is the difference between xiRIAD and Radic Solution?
Who will answer? So,
Yeah.
yeah, xiRIAD is successor of Radic Solutions. We got rights to develop solutions based on some Radix IP, and we spent 2 years developing new features, achieving new results. So the main difference is 2 years development of on xiRIAD. This means we have more features, we have much better performance, PCIe PCIe 5 configuration, because we did a lot to support PCIe 5 based solutions.
Yeah, also it's very important to sign that the company is named Xinnor, and but here the question is about differences between xiRAID and Radic Solution. So it's not really clear what the question is about. Yeah, but the Radix company doesn't exist anymore in Russia, as we know, if the question was about that.
Yeah. Yeah, and let me add as well some words here, because what is Xinnor strategy? All that we develop, it's about performance, and all our competitive advantages at the market relates to the performance, both for NVMe installation, HDD installation, and hybrid installation. And as well, it's our main idea that drive all our business. That at the present moment, we have so many industrial trends in the market to present new hardware technologies, new software technologies where performance matters. It's both related to the applications, to the AI application, HPC workloads, real-time applications, and so on. And we see that our market where performance matters growing even faster than we do all our solution at the present moment. Therefore, we believe that all the ideas based on performance is the main caterpillar of our business. And as well, we are working hard at the present moment to present you in the future disaggregated storage solution for HPC industry as well. With the great numbers that Davide present on the slide received this Kioxia testing. We do some activities at the present moment with some GPU vendors, especially NVIDIA, to present as well solution for HPC, where we combine our storage with disaggregated calculation nodes.
Okay, let's move on with the other question. Who do you see as a competitor in the current market? So let me address this question. So from one side, we are basing our solution on commodity hardware. So you might think that we are competing with homemade solution, do-it-yourself type of solution, which lack the reliability and the performance and the validation that we are doing, because a big portion of our time is spent on making sure that all the software codes that we are developing works well over time. Then if you want to look at what's readily available from OEM vendors, probably the closest competitor is DDN Exascaler. So the architecture of their solution is not that different from the one that we have on xiSTORE. The main benefit that we bring, besides performance and data integrity, is the fact that our solution is based on commodity hardware, and by doing that, we can get the price point of the overall solution, which is not comparable. And then there are many other vendors in this market offering distributed file system, fully integrated with their own software development. Each of them, they have different positioning, different targets. So we might come across other competitors at other projects, but just in brief, those are the two main ones that we see. Okay, then the next question is, if xiRIAD is not network RAID, will not erasure coding provide better resilience in terms of node failure? Maybe Daniel or Sergey.
Very good question. The simple answer, yes, of course. Erasure coding provides better approach, better resiliency than RAID with dual node configurations. But only reason we started with dual node configuration is market is very familiar with dual node configuration, and market asked us for dual node configuration. Is basic configuration for Lustre. And for future, yes, we are working on N+M approach, where we'll be able to use disaggregated storage resources with override engine, which also support N+M erasure coding scheme, and also N+M failover be much more resilient than 1+1 clustering. So yes, we see that 1+1 cluster is not optimal configuration, but widely used on the market, and we see that for future for us is N+M configuration with disaggregated storage resources.
Let me try and answer. Let me try answer this question. So yes, Lustre has a very specific realization of erasure coding. But if you want to manage it on the Lustre level, let's imagine how you would like to organize it. For example, if you have, you need to create OST somewhere. If you will create OSTs directly on the drives, when you will have, for example, you have a system with a large volume of storage, for example, 400 drives. So you will need, in this case, if you would like to create OST on the drive level, you will need to create 400 OSTs, which is not very useful in terms of management. So anyway, even in this case, it's better to create it's better to create some RAID, and then if you want using it, if you want, you may also erasure code some specific files. Because in Lustre, basically erasure coding works in such a way that you write file, then you need replicate it with specific command, and you need to run this command after this file modification, to make the erasure coding consistent. So it's very specific Lustre configuration. So in general tasks, it is really better to use standard RAIDs. But if you suppose, if you want using, for example, a Lustre installation with with no high availability clusters, you may use erasure coding. And also, if you want using, if you wonder if you can lose all the building block, in this case, erasure coding over this building block, over the Lustre may help you. But the realization of erasure coding as a replacement for RAIDs, I don't see any place for such solution here. At least at this level of the realization.
Yeah, in any case, we like approach which Microsoft has. Microsoft names it local reconstruction codes, where some parities are used to take care of these local errors, not to load cluster network for simple single drive failures, and also they has some additional protect in case of full node failure. So you can utilize the same approach to using RAID as a which will be responsible for a single or dual drive failure, and in such case RAID will take care on some single drive errors and will not affect client's performance, and you will be able to use erasure coding on Lustre side to protect from whole node failure. It's one of possible configuration. We don't test such configuration a lot. I believe it. Some of our work for future.
Okay, one more question. Can support boots OS drives?
Here I think we need to understand. What is this question about, because I understand this question in terms of our xiRIAD engine. In this case, our xiRIAD engine does not support booting. Yeah, but for sure, our complete solution, xiSTORE, supports mirroring of the hard drives. In this case, we don't use our own RAID engine. We use other RAID engine because basically our bare metal installation is based on Linux, and we use the Linux. But in this case, we will support mirroring of the server's boot drives.
Okay, let's move on. We are short in time. Is InfiniBand an absolute requirement, or this solution can work with Rocky and TCP?
Well, most probably no. Most probably we will not have such limitations, because basically with InfiniBand or Ethernet card works our virtual machine with running standard Linux with standard drivers. You always can install these drivers or use the standard Rocky driver. So it should work, but the problem is that for now we have only all our lab systems are InfiniBand, but I'm sure that Ethernet should also work without any problems.
Yeah, the only limitation, you should have adapters support IOV technology, because you need somehow to pass devices to virtual machine.
Okay, we have one last question. Has xiSTORE tested its performance? Xinnor tested its performance advantage in real application, for example, OpenFOAM?
So, okay, again, simple answer. We test our performance advantages in real applications, but we do this only with in cooperation with our partners. We have partners with some real case scenarios. In such case, we do some performance testing cooperations. We have different partners from different industries. Talking about OpenFOAM, we have not tested OpenFOAM application because we have no. We, as a startup, we can't have competitions on almost all software which present on the market. That's why we need some partners who expect some.
And we will be happy to work with you, Max, eventually to test it if you have a requirement. So that's normally the way we do testing on the applications. As Sergey said, we work with our partners. And most of the time when it comes to HPC, we don't provide a readily available solution. We need to do some tuning and some customization. And we do have this experience of tuning and customizing the solution based on specific workload or specific customer requirements. Okay, we're at the top of the hour. We are out of time. Thanks everyone for attending. We will make the slides available to whoever register, and the recording will also be available for review in the future. So thank you so much for attending. Hope you have a great day. Bye-bye.
Thanks.